Hi everyone, welcome back to Life Technologies YouTube channel. I hope you're doing well and thank you so much for watching and continuing to support our content. So this is another episode of our Juniper Lab simulation series, and in this episode we'll be demonstrating how to implement link aggregation on Juniper routing devices. So we know that link aggregation is a very common networking technology, especially for service provider networks, both carrier and enterprise networks. And if you are working for a small office network, definitely you may not interact with link aggregation. But if you are working for a service provider or a carrier network or even a campus network or even a data center, you will end up interacting so much with the link aggregation. So link aggregation, it's a very common networking technology that allows us to bundle multiple physical links into one logical link. So we are taking, let me say, for example, 2 or 3 single links, and then we are bundling them into one logical link. So this logical link ends up having a higher capacity depending on the configurations. Remember, sometimes you can configure the minimum number of links that you want to be active. You can configure the maximum number of links that you want to be active. So depending on the configuration that you have done on your router, it will determine the capacity, the end capacity that you will have on the logical link. So that is one advantage of link aggregation. It helps to increase on capacity or the bandwidth between the two devices. Another advantage of link aggregation is on the network resiliency or network redundancy. So when you are bundling these multiple links into one logical link, remember many times it's a best practice not to pick ports on the same card. And once you've picked ports on different cards and maybe there is a card failure on one of the devices, traffic is able to switch on the remaining active links. So it helps to improve on network resiliency or network redundancy. So those are the two main advantages of link aggregation. So this lab will be focusing on how to implement link aggregation on Juniper routing devices. And from the topology, you can see that we have two devices. We have VMX01 and VMX02. And between the two devices, we have three back-to-back connections on GE00, 01, and 02. So we'll be configuring link aggregation between the two devices and adding the three links into our logical link. So of course, when you are doing the link aggregation configuration, many times you have to first enable the link aggregation on Juniper devices, and then you need to create your link aggregation group. And the third step is to now add the independent or the single link that you want to be part of this link aggregation group. Once you've done that, you can now go ahead and do other configurations like which LSCP mode you want. It could be active active or active passive. If you configure it to be passive passive, definitely your LSCP will not come up, your link aggregation group will not come up. So for this lab setup, you can see that you have the connections. Let me show you the setup in EVNG, similar to the one on the PPT. So with this setup, we'll go ahead and start our configurations. So I'm logged into the two routers, router 1 and router 2, just so that we are able to see the topology and the setup. So from VMX1, if I show you the current configuration, show configuration, display set, these are the configuration that we have. We don't have anything to do with the link aggregation. So the first step that we need to do is to enable some link aggregation groups. So you are configuring how many aggregation groups do you expect to configure on this router. That is always the first step when you are configuring link aggregation on Juniper routing devices. So the command will be to set chassis, aggregated devices, and then we need to specify its Ethernet, and then we configure the device count. So the device count is the number of link aggregation group that we'll be configuring on these devices. So you can use a question mark. You can see that we have 1 to 480. For our case, we only need 1, but I will configure it to be 5. So when we run show pipe compare, you can see that we have the device count set to 5. We will do a similar configuration on this VMX2. So it's set chassis aggregated device Ethernet, and then the next one is device count. We make it 5. When you run show pipe compare, we expect a similar output. So I can commit on VMX2, can also do commit on VMX1. So once we have done that, we can now go ahead and configure the independent links. Remember, we have GE00, GE001, and GE002 should be part of a link aggregation. So if I run show interfaces brief, now let's use the task so that we can see. So you can see that currently we have A0, A1, A2, A3, A4. So we have 5 aggregation groups. Same to this one, run show interfaces task. You can see that we also have A0, A1, A2, A3, and A4. So we are allowed to configure 5 aggregated links on these routers. So the next step is to now add independent links into the link aggregation group. We'll be using the link aggregation group A0, and the command is you set interfaces. We are using GE0. This is G0/0/0, and then we need to use the gigabit options. You can always use question marks if you are not familiar with the command. So when you run these gigabit options, you can see the option that we have. We are looking at IEEE 802.3AD. This is the link aggregation control protocol, the LSCP protocol that we are configuring. So I just need to specify 3AD, and then I specify the link aggregation group A0. So we can run the same command for the second interface and the same command for third interface. Show pipe compare. You can see that we have interfaces G0. We have configured it under this link aggregation group 0, both 0, 1, and 2. So on VMX2, we do the same. So it is set interfaces G0/0 giga Ethernet options, and then 802.3AD. We are missing the link aggregation group, so this is A0. Then we do the same for the second interface and the third interface, which will be 002. Show pipe compare. So you have these configurations. I will commit. And then another thing that we need to do is to configure the mode. So starting with this, let me commit on this router 2. So we can show run show configuration, and then pipe match. If we check A0, then display set, so that we are able to see these are the configuration that we have applied. And then the second step is to set interfaces A0, and then we can configure the LSCP mode. So aggregated Ethernet options, LSCP mode, will configure it to be active. We'll start by configuring it to be active, and then we can go ahead and demonstrate if we configure it to be passive, whether it will come up. Of course, it should not, because at least there should be one that is actively sending the LSCP packet. So on VMX2, we'll do the same. Show pipe compare. We have set it to active. Another thing that we need to do is to now configure an IP address on this aggregated group. So we can use the same command as we used in our last episode, said interfaces A0. We still need to use the logical unit. Remember, in Juniper there is the concept of logical units, kind of the sub interfaces on other vendors. Unit 0, and then we set family to inet, and then address, this should be 10.10.10.1, mask is 31. So I can run the command show pipe compare. You see we have configured the LSCP to be active, and then this is the IP address assigned. So we'll do similar configuration here. Set interfaces A0, unit 0, family inet. This is for IPv4. Address, this is 10.10.10.0, mask is 31. Show pipe compare again. You have the configurations, commit. So on this router we can also commit on VMX2. So finish to commit. You can run show interfaces A0. You can use brief. You see that enable the link is up. We can run ping. This is on VMX1. Run ping 10.10.10.1. You can see that we are able to ping the IP on VMX2. Here also we can run show interfaces A0. You can check. We have multiple options: detail, extensive. So when you use extensive, of course, it will give you much more detail. Let me just expand this. We have much more detail. We have the interfaces, which one are the actor, which one are the partner. Both all these details negotiated through LSCP. You can see our ping is okay. On this router, we can also try to ping. Run ping 10.10.10.0. You can see that we are able to ping the IP on VMX1. So again, to show you the configuration, run show configuration, display set. We can see everything. You can see that these are the configuration that we have used. First, to set the number of aggregated group that we're expecting to configure, and then we add the 3 interfaces into the link aggregation group A0, and then we set the mode. The LSCP mode can be active or passive, and then we configured an IP address on unit 0. So when you show exit, show interfaces stars, you can see that now these interfaces are indicated to be part of A0, aggregated Ethernet A0. On VMX1, I can also exit, show interfaces stars. We also expect the 3 interfaces to be part of the aggregated Ethernet group 0, and we have an IP address configured for unit 0 on that aggregated Ethernet group 0. Let's show LSCP interfaces. When you show LSCP interfaces, you can see that all these are, and they are all active. So let's try to configure this router to be passive. So CLI, back to CLI, and then show configuration, just display set to see what we have. So what we'll do is we will delete. So when you want to clear some configuration, normally we are using the delete command. So I will delete interfaces, or I can set it to LSCP mode active. Let's try to set without changing it and see. So if I try to make it passive, show pipe compare. So it works. We are moving the passive active and adding passive. So commit. Definitely this one should work. So show LSCP interfaces. You can see that now it's passive. So the mode on this router has changed to passive. Let's go to this device and do the same. So if I show interfaces A0, before I do that, you can see that link status it's up. So if I configure and then I set interfaces A0, aggregated Ethernet options, LSCP passive, show pipe compare, and then commit, go back to VMX1, show LSCP interfaces, show interfaces A0. You can see that the link is now down because both ends are now passive. So the link will be down. No one will be initiating the connection. Show interfaces A0. You can see this side it's also down, and the reason is we have configured it to be passive. So for us to bring it up, we need to configure one side to be active. You can configure set interfaces A0, aggregated Ethernet options, LSCP active, commit, exit, show interfaces A0. You see that the link is now back up. We check on this other side. The link is now up because they are able to negotiate the LSCP parameters, and now the link comes up. So this lab was just a simple demonstration of how to configure LSCP or link aggregation groups on Juniper routing devices, and we've mentioned the two benefits of link aggregation: increasing capacity and also improving on network resiliency or network redundancy. So for the configuration, let me just show you before we close. Your configuration display set. You can see that these are the configuration, these are the lines that you want. Of course, you can configure many other parameters on link aggregation, but for you to get up and running, these are the basic configuration that you need to make. You need to configure the device count, the aggregated devices count on each device, and then you can bind the single interfaces. You add them into the aggregated Ethernet group that you've chosen, and then you need to configure the LSCP mode. You advise to configure one side should be active. So it can be active passive, but if you configure passive, your link will fail to come up. So I hope you've enjoyed this session, and if you have any question, feel free to leave it in our comment section. Like this video and also to share with your network. And also just remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.